Hello everyone, this is Snigdha. Throughout this presentation, I'm going to discuss about a fast file system for UNIX. The topics I'm going to cover in this presentation are what is file system and its uses, the old file system, the problem caused due to the old file system, how new file system came into place, its performance, function enhancements in new file system, and the conclusion. What is file system? A file system is used to store and retrieve the data in a storage medium. The most important purpose of this file system is to manage the user data. Without a file system, it is difficult to store the data as the data looks like a large body on a storage medium, and we would not know where the piece of data ends and where it starts. Now we will see about the old file system, the problems caused by old file system, and then how new file system came into place and its performance. Now let us discuss about old file system. This old file system is also called as original Unix file system and also called as traditional file system. This is developed in Bell Laboratories. Here, the disk drive is divided into one or more partitions, and the divided partitions will contain the file systems. And the file system is described by a superblock, which is denoted as S. And this superblock contains basic parameters like inodes, pointer for the free list, and linked list for the free list, and it also contains the number of data blocks present in this. An inode is a data structure in the Unix file system which consists of the information regarding the ownership of the file and the access time for the file, the timestamps which gives information regarding the last modification done to the file, and also an array which points to the data blocks of the file. This is the picture of an inode and this is how it looks like. It basically consists of the owners, the timestamps, and the direct blocks. Inodes are stored in the inode tables, and there's an inode table in every block groups in the partition. The old file system was simple and easy to use as it is a step forward from the clumsy record-based storage systems in the past. But we do have problems with the old file system. In the next slide, we are going to see what are the problems caused by the old file system. The main problem with the old file system is its performance, as the performance is terrible because it was delivering only 2% of overall disk bandwidth. And the old file system is treating the disk as a random access memory. So the data is spread all over the disk and this causes the expensive positioning costs. The free space in the old file system is not properly managed. So the logically contiguous file would be accessed by going back and forth. This will seriously reduce the performance dramatically. This is one of the problem caused in old file system. There is also another problem caused in old file system, that is due to its block size, which is 512 bytes. The original block size of the old file system is too small, which is 512 bytes, and the transferring of data from the disk was insufficient and it is really difficult. To overcome these problems, few modifications were made in the Unix file system on both reliability and throughput so that the performance will be improved. The reliability was improved by staging the modifications to critical file system so they could either be completed or repaired cleanly by program after the crash. The performance was improved by increasing the block size from 512 bytes to 1024 bytes. This gave an indication that by increasing the block size, throughput can also be increased. Although the throughput is improved, there is a still problem with the old file system as it is still using only 4% of the disk bandwidth. Let us now see an example which shows that the old file system is using the disk as a random access memory. For example, if we consider a following data block region, which consists of four files like A, B, C, and D, each of two blocks, so that A will be A1, A2, B will be B1, B2, C will be C1, C2, and D will be D1, D2. If at all, if we remove file B, that is B1 and B2, and file D, that is B1 and D2, the resulting layout will be in this way. Here we can see that the free space is fragmented into two chunks instead of a contiguous chunk. And if at all, if we wanted to allocate a file E, which is of four blocks, then it will spread all over the disk, hence we would not get a sequential performance. This is the reason we are saying that the old file system has a poor performance. Even though the reliability and throughput are improved in order to increase the performance in the old file system, we are still getting poor performance from the old file system. For this reason, a new file system was introduced. The goal of this new file system is to improve the performance of the implementation by keeping the same interface of the old file system. This is also called as Berkeley fast file system. The first step of the new file system is to change the structure of the disks. This fast file system divides the disk into one or more cylindrical groups, and these cylindrical groups consist of one or more cylinders on a disk. The fast file system is described by its superblock, which is denoted as S, and the minimum size of the superblock is 4096 bytes. The fast file system keeps a copy of superblock in each of the cylindrical group for reliability reasons. If at all one copy becomes corrupt, you can still mount and access the file system by using the working replica. In order to improve the performance of the fast file system, the fast file system uses the following principles, like duplicating the superblock so it can be easily recovered if at all a crash occurs, and using a large block size to improve the throughput, and adding the block size to the superblock, storing the related data blocks within the cylindrical groups, and most importantly, storing the small data files in the fragments. This is of the fast file system has divided the disk into cylindrical groups. Now let us see how efficiently small files can be stored in fast file system by using large blocks without any wastage. Consider a file in the fast file system composed of 4096 byte data blocks, and in the old file system it will be composed by 1024 byte blocks. By increasing the block size in fast file system, we can transfer 4 times as much information per disk transaction. But here the problem is Unix file systems are composed of many small files and a large block size wastes the space. To use these large blocks without wasting, the small files are stored by dividing the file system block into one or more fragments. The size of the fragments is specified at the time of the file system is created. To explain it briefly, now let us consider the blocks and fragments in a 4096 by 1024 file system. Here there are 4 blocks and each block has 4 fragments. The X denotes that the fragment is in use, and 0 denotes that the fragment is free. For example, from 0 to 3 fragment numbers, the fragments are full and they are in use. And here the 6, 7 fragments are free. Here 8, 9 fragments are free. But from 6 to 9, we cannot use it as a full block. It means fragments of adjoining blocks cannot be used as a full block. For example, if we consider a 11,000 byte file which is stored in 4096 by 1024 byte file system, here the file will use 2 full blocks, that means 2 full blocks, and one 3 fragmented portion of the another block. If no 3 fragmented portion free block is available, A full-size block is split into the necessary fragments. That means out of 4 fragments, 3 fragments will be covered into this 11,000 byte file, and there will be one unused file, and this unused file we can use to store small files as needed. In this way, we can store the small files in the fast file system using large blocks without wasting the space. Here, both the tables shows that the improvement in the performance of the new file system when compared to the old file system. Here, both the reads and writes are faster in the new file system when compared to the old file system by using the larger block size. Some tests were performed on both the types of file system, that is old file system and new file system, using different buses which are like unibus and mass bus. The only difference between the unibus and mass bus is the controller which was used, and we can clearly see that the improvement in the speed and the bandwidth of both reading and writing of old file system and the new file system. The speed of the reading rates in the old file system is 29 kilobytes per second, and whereas in the new file system it is 221 kilobytes per second. In the same way, the bandwidth also has an improvement. Whereas while coming to the writing rates, the speed and the bandwidth were more and increased in the new file system when compared to the old file system. So togetherly these shows that the performance has been increased or improved in the new file system when compared to old file system by increasing the block size. As the new file system required all the existing file systems to be dumped and restored, the following functional enhancements were introduced, like long file names, file locking, symbolic links, rename, and quotas. The fast file system was the first file system to enable the long file names. It enables more expressive names instead of traditional fixed size approach. File locking. While trying to create a log file to synchronize the process updates in the old file system, if succeed in the creation of the log file, it is fine. But if at all the creation of the log file fails, there are few drawbacks. To overcome the drawbacks, the new file system has created a mechanism for locking the files. Symbolic links. New file system introduced this function, which is used to create an alias name for a file or the directory in the system. Rename. Rename system call has been added, which generates existence of target file name. Lastly, quotas. It means it is a function which sets a limit on how many inodes and how many disk blocks are used by a user, so that it can allocate accordingly. Throughout this presentation, we have seen what an old file system is, the problems caused by the old file system, how new file system came into place, and the improvement in the performance of the new file system. To conclude this presentation, we can say that the introduction of the fast file system in the history of operating systems was like a watershed moment, as it has made clear that the problem of file management was one of the most interesting issues in the operating systems. It also made clear that we should treat the disk as a disk and not as a random access memory. It also showed that the small files can be stored in the fast file system in a more efficient way by dividing the file system blocks into one or more fragments. Thank you.